Very good evening to one and all. First, I would like to thank all the participants for taking your precious time to join us for today's webinar. On behalf of IEEE Site Bangalore section and IEEE IAC student branch, we welcome you all to the today's webinar, Emerging Technology with Focus on IoT and Cloud Cybersecurity. Now, I would like to invite IEEE Site Chair Professor Hanandi Giridharan ma'am to give few insights about today's event. Over to you, ma'am.
Yeah, thank you, Sangeeta. A very good evening to everyone and a warm welcome to today's event on emerging technologies with focus on IoT and cloud cybersecurity perspective. First and foremost, I would like to thank our speaker, Mr. R Vittal Raj, cybersecurity consultant and trainer. I would like to thank all the participants again for this event. I am Anandi Giridharan. I am with ECE department as Principal Research Scientist at IISc. I'm serving as IEEE IAC Student Branch Counselor and also Chair IEEE Site Bangalore Section and Vice Chair to IEEE Hack India Council. IEEE is the world's largest technical professional organization for advancement of technology with more than 4 lakhs plus members. And IEEE Bangalore section is one of the most vibrant and dynamic IEEE sections across the globe. And we have IEEE IAC student branch is recognized as one of the best student branches by IEEE, and it is under IEEE University Partnership Program along with 17 other colleges in the world. IEEE Special Interest Group for Humanitarian Technology is a global network of IEEE volunteers ecosystem partnering with NGOs and communities and to co-create impactful solutions. We perform outreach activities, technical training, like the one now we are going to conduct, so that IEEE volunteers, especially the students, will know how to use their technical knowledge and skill for social good and obtain the required skill to bring about change in the society. Is important because it protects all categories of data from theft and damage. It includes sensitive data, personally identifiable information, and protected health information. And also informations like personal information, intellectual property, data, and governmental and industrial information system. Let's learn more in detail from this session from our cybersecurity expert speaker, Mr. Vittal. Over to IAC PhD student Kunal for introducing our speaker. Kunal?
Yeah, yeah, yeah. Hello everyone, I'm Kunal, a third year UG student at ISC and the current chair of CSCI's Joint Society at the IEEE ISC Student Chapter. I would like to introduce today's speaker, Mr. R Vittal Raj. Vittal is a risk assurance and cybersecurity controls professional and trainer with over 25 years of experience working with clients in a wide range of industry verticals on IT governance, cybersecurity, privacy, IT assurance, enterprise risk management, and risk-based internal audits. Vittal is an FCA, CISA, CIA, CISSP, CGEIT, CISM, CRISC, and CFE. Vittal is also a member of the RBI Standing Committee for Cybersecurity and IT Examination and a member of IRDA Information Security Group. Vittal has earlier served for 2 terms as the International Vice President and Director of International Board of ISACA IL USA and was awarded with the President's Award and Certificate of Appreciation for outstanding contributions during his term as director. Vittal has also served on research and technical committees of ICAI-India, IIA Florida, ISACA International, ICWAI, and GC member of MCCI. Vittal is a founder and senior partner of MS Kumar and Raj, Chartered Accountant leads and manages the information and strategic risk assurance services practice across diverse business verticals since last over 3 decades. We will have a Q&A session at the end of the talk, so I would encourage participants to post their questions in the chat. I would now like to hand over to Mr. Vittal for the commencement of the session. Yeah, thanks. Over to Mr. Vittal.
Yeah, good evening to everyone. Thank you, first of all, IEEE for this invitation, especially Supriya for having coordinated this. And thanks for the kind introductions from Dr. Sangeeta, Dr. Anandi, and Kunal. It is indeed a pleasure to be here. So you have a kind of an offbeat session, if I could say. You've always been doing more and more of technology and focused on a lot of technical content. Here we are going to look at something that matters, whatever you do for the business. And if that's not going to be really working, whatever you do is not going to really pay off. So that's where this particular session is going to be a combination of what we call as governance, risk, compliance, as well as, of course, touching upon technical risks. Of course, I'll encourage as much of interaction while I have a couple of slides. I don't intend taking you to each and every slide, but then the idea would be to give you certain key insights into some of the aspects that are relevant for the topic of this particular session. I hope you are able to see my screen.
Yes, sir.
Wonderful. So let's go ahead. So this particular session is focused on the Internet of Things and the cloud. Of course, we'll be touching on a couple of other emerging tech as well, because everything is going to be integrated into one large fabric of what we call as the digital economy. And that's where I think we are going to see a whole lot of action and activity, which is going to be at a kind of rapid pace, which we have never seen before. So first, let's look at where we are. And I think it's important to understand and set the context. I mean, if we look back, I'm sure much before many of us were even seen anything of this kind, we have certainly studied about the first industrial revolution. And if you see, that was recognized as the first because of the significant contribution that the mechanical and production facilities made to the human mankind, especially with the water and steam power. So you can imagine that had you been before those times, and if you did not have steam power, you can imagine how things would have been done. And then we go on to the second revolution, which was obviously about electrical energy. And that created a complete revolution through the industries. And, we know what happened after that. The third one, which I'm sure many of us are reasonably familiar with, and we are riding on this wave, is that of the electronics and IT systems. And that is where, if you see, the Bill Gates and the Microsofts and all of them really became so popular, right? Starting from the first, the mainframe computer that was devised for the first time and discovered somewhere in the corner of the US. But then what we have been seeing is we have been simply riding on that, and slowly we have seen that there was a time when we said that, okay, the physical can never meet the digital, but then I think the time has come and we are seeing that happening, wherein we are in the fourth industrial revolution, which is called as the phygital revolution, wherein you have the handshake between the cyber and the physical systems. And that is one of the areas that we are going to touch in today significantly. Of course, we'll be also looking at what powers all this, which is also part of the cloud infrastructure. Just looking around and what has been happening across times, some of these technologies are already mature enough, and we have already seen significant amount of applications right across in wherever we see in our lives. And if you remember, this was one of the kind of news flashes somewhere way back in 2016-17, when they said that Dubai is going to be the first country to test drone taxi services. And of course, the drone taxi service has not really taken off, but the drone ambulance certainly has. But then in context, if we are looking at the future of mobility. I'm sure many of you might have heard about this movie called Star Wars. And I'm sure of the earlier genre, if you would have seen a couple of these episodes of Star Wars, which was a super hit. And we had only seen those, the kind of spaceships and the kind of mobility vehicles, which were a dream, but then all of them is really turning out to be true today. And we are going to see more and more of completely, disruptive mobility that's already happening way around. And we are going to see a lot of that happening. We are already looking at the Hyperloop, which in fact, our country too is going to get somewhere in the near future. and we have always been looking at newer and newer ways of how can we really make mobility of people and things as easy as possible. I am sure you recognize this. This is when the first robo and who was publicly recognized, and her name I'm sure you know is Sophia, and she, if I can say she, or I can't say it, because she had a lot of artificial intelligence built into her. Not only that, she also addressed as a keynote speaker in a conference in Hyderabad. I'm sure some of you might have attended that, and she gave a talk on how human value, and this is a robo speaking, mind you, human value would participate to the growth of the world as a whole. So that's where we stand. We have really moved a lot from there. We have heard about Akira the robo and a whole lot of things. So we are now, kind of looking at robos. We are near kind of the way that you humans would interact, but then that's still a little far away from us. But then we are already talking about humanoids, and which we have been only seeing in science fiction movies. The future of money for the first time has changed ever since man came and discovered himself on this planet, when we were using barter system, but then we went on to fiat currency, and we have been living with fiat currency across generations. But then suddenly we heard about something called as the cryptocurrencies, and that's kind of completely changing the way we look at cash. And I'm sure many of us here would hardly be using much of our own fiat currencies. So we are so used to the mobile banking and mobile cash that we hardly think about that. I'm sure we have also investors in a couple of these cryptocurrencies here. And if you're not tried one, well, I wouldn't encourage you, because that's not completely legal in India. But then at the same time, if you already experienced that, that's wonderful. Then we are looking at the worlds beyond, and that's where the metaverse is coming. In fact, I would think our country, we have been in a way one that discovered the metaverse. In a way we can call that. Reason being, we have been talking about the 3 lokas. If you see right across, the bhuloka, the swargaloka, and the narkaloka, then the 14 lokas. So we have seen all this, and that's where metaverse is kind of looking at making a start in our today's more of mundane lives, as to how it bring in the experience of other worlds, and which is going to be fascinating, though yet in its very, very nascent stages. So if we, clockwork back and look at 2020, and one of the key leaders in technology forecasts, which is Gartner, and what did they say about the top 10 strategic technologies for 2020? And mind you, if we start taking stock of where are we on that, you would find that most of them have already materialized into applications that are working in public life. So you have hyper automation, you have multi-experience, you have democratization, human augmentation, transparency, traceability, empowered edge, distributed cloud, autonomous things, practical blockchain, and artificial intelligence security. Many of them have been either needs or problems that we have faced earlier. But then that's where, if we look back and look up today, I think what appeared to be, which is more of concepts, has certainly turned into reality today, or are in the process of really getting into more and more integrated with our lives. But then let's look at what are the forecasts for 2022 from Gartner. And these are more interesting. Now, mind you, everywhere as an engineer, you should be concerned at, okay, what am I working on and where am I going in terms of the current technologies? Am I working on archaic technologies, or am I something looking at the future? Because we are already into low code and no code platforms. So the future of programming, or the software sector, which powered the the GDP of our country and has been doing that for quite a number of years, is certainly going to change in much different ways. But then there are so many new opportunities as well which are coming up. So it is important for every engineer to take cognizance about what kind of technologies are emerging, especially the autonomous ones, and see that, are you really there when you come out of your completing your studies into the market? Will you be useful to the society or not? And that's going to be important question to ask yourself. Am I relevant? Will I stay relevant? And that's where, beyond just your courseware that you learn, you have to understand that by the time you go to sleep and come the next day morning, the technology has already moved forward. So that's where it is important to understand that while the course curriculum cannot keep in pace with the current technology, but you got to, because otherwise you are outdated by the time you are born in your career. So it's important that we consider each and every aspect of technology and look at the common sense foundations and make sure that we would be useful when we come out in the society. So if you look at 2022, it talks about data fabric, a very important concept called as the cybersecurity mesh. We'll be talking a little bit about that when we talk about the cloud. Privacy enhancing computation. Dr. Anand just spoke about the importance of privacy becoming more and more legal. We have already seen the data protection bill that was introduced in the parliament. Unfortunately, it was withdrawn this session, but then it is only going to come back with more rigor in the coming years. We already have the GDPR, which every system got to be compliant with to make sure that privacy enhanced computing happens. And that's going to be a kind of a key principle in architecting any technologies for business systems in the future. Of course, we are seeing, thanks to the pandemic, significant movement onto the cloud. Many of us who never thought about going to the cloud have already gone to the cloud. Especially, I'm talking about the elderly at home who may have been very kind of not so happy with using the mobile for their banking transactions. But then thanks to the pandemic, it has kind of pushed that pointer forward. And you see that it's kind of become a breeze and you don't really want to go back in terms of your physical experience with a bank. And that is where, if you look at what's happening to the banking and financial sector, there is a huge transformation. The banks of today will be dead in another 5 years. I'm not saying that, Gartner says that. And if you really look at it, the banks are going to embed into the fabric of the economy. So whatever systems that you develop, somewhere it will get connected to a banking or a payment system. And that's very likely to happen. So that is where, if you really look at the kind of applications that are coming up, especially in the fintech space, they are humongous. And that's where you look at the turnaround time for applications has been crushed from the waterfall model, which we used to follow a long time back, to something which is agile, but then we now call it as the super agile model, wherein before you think, you got to be intuitive to say, okay, what's the application going to look at tomorrow morning? So application development is no more some back office work. It's something which is happening on the front. And that's where, that brings in tremendous amount of artificial intelligence and machine learning. So the decision intelligence, the hyper automation are something which are all near reality in many of the scenarios. And we could see that suddenly coming up everywhere. Artificial intelligence is no more saying that, oh, good thing to have. It is something which has to be kind of looked upon as adding continuous value to the system. And we are looking at, thanks to the pandemic, distributed enterprises, wherein even today hiring organizations, if you look at the kind of ads, they say, okay, we have a work from anywhere principle. So we don't want you to come to the office. You just work from wherever you are. We don't care. And then this total experience of making sure every stakeholder of the system benefits from the kind of intelligence and technology that we are building. Not only that, I'm sure we have seen autonomous systems coming up everywhere. And we are looking, we looked at several of the operating systems which came with the autonomous repair. And now we are looking at autonomous cars. We are looking at autonomous vehicles. We are going to look at a lot of autonomous systems in the coming future. The big challenge always is going to be, how do you ensure that they will work as they are supposed to work? And when it comes to AI, we are looking at generative AI, wherein the system learns by itself and without any mistakes gives you the use cases which are innovative and on the fly, completely developed by the system. So if you really look at, there is a huge responsibility today as compared to a couple of decades back, when you could say, okay, I am a programmer. Well, you can no more just survive as a basic programmer. You got to look at the big picture. And if you do not know the big picture and you're simply just working on something where, oh, because I was asked to work on it, you are going to be lost. So it's very important to make sure that whenever and whatever you're doing, whatever you're learning, whichever project you're part of, you always question the big picture and say, why the hell am I doing whatever I'm doing? What is it going to contribute in terms of the human mankind experience? And that's where I think the real test of your being successful in the long run is going to be. Well, this IoT, we are going to get into IoT for some time. And if you really look at, I'm sure all of you know that it's the popularly known as the Internet of Things, the Internet of Everything, Internet of whatever, all that is there. There are a lot of acronyms attached to that. But then the big question is, okay, I don't even know what is IoT. So I have not seen it work. So how does it work? I only seen that in movies. Well, let's look at it. Are you using IoT today? I'm sure you are going to tell me where you will find all this, right? An accelerometer, gyroscope, a magnetometer, a GPS component, a proximity meter, an ambient light sensor, of course a microphone, touchscreen sensors, fingerprint sensor. I'm sure you'll be able to guess where all this work from, right? Any guesses? Well, it's all in each of our hands. We are tied up to, that's the mobile, right? So the mobile, if you really look at a whole lot of IoT sensors, devices, which are already inbuilt and we are using it in day-to-day lives. In fact, as we know that many of these mobile service providers, and if you are on Google, they all know what is the tilt of your mobile, where are you, what you are using, everything technically is possible to be found out. So there is a whole lot of data that flows back to your various service providers and your vendors and manufacturers, etc. Technically, that's possible, even though that presents you with a very huge risk. Now, if you really look at, our day-to-day lives today, we have added a lot of these apps to our mobiles, like the pedometer, the barcode scanners, which are all downloadable. You got iPhones which come with barometers. You have heart rate sensors which are very effective. You have thermometers, of course, which are built in, air humidity sensors, and the Geiger counter, the radiation sensor. So these are kind of getting added more and more into the mobile. In fact, if you really look at a mobile, it is couple of if I can say at least multiple times more powerful than the first mainframe system that was found. And if you really look at the kind of power that you have in your hands, and it is only going to increase, we are looking at tremendous amount of capabilities already coming into that. In fact, the scientists are already working on a smell sensor, wherein a lot of prototypes have already been done. So you could smell from your mobile what's being cooked at home. So where we are going, we don't know. It's pretty crazy. But then if you look at the technology, it's enabling everything that we thought was impossible. So how long has IoT been there? Well, if you guess, 1967 is when the first IoT actually was launched in the true sense, because there was something which could sense a temperature, and it could be used as a reading in the machine, and it could then turn down the heater or turn on the heater. So it's pretty long been there. Look at one of those examples in our daily lives and how many of these products are already bringing in tremendous amount of these integrated technologies, of course, with IoT being there. I'm sure you see what's on the screen. It is just a toothbrush, and it is from a very, a kind of innovative company called Colibri, and it's a pretty popular brand today. So what's funny about this toothbrush? It's any other toothbrush. So what's so great about it? If you really look at the marketing piece that Colibri comes with, it says gentle bristle. Well, makes sense. Multiple brushing programs. What are you talking about? Then changeable brush head, Bluetooth communication module, wireless induction charger base, elegant design. I am sure a couple of us have already got this gadget at home. It is completely an autonomous toothbrush, which can, you wake up in your half meditative state of the morning, and the one thing that you don't do properly is always brushing your teeth. And that's where most of the problems comes from. But then this toothbrush not only helps you with that, because you don't need to really move your hand, it will make sure that it will make you move your hand with the kind of sensors that detect, which parts of the mouth are not getting done. How does it do that? because as you saw, it has a Bluetooth communication module, which provides a mobile app. And if you look at those screens carefully, the left-hand side of the screen tells you where or you did not brush properly. So once you are in your out of your meditative states and you have had your morning coffee or whatever, and then you wake up and look at, oh my goodness, I have not really brushed these parts of the teeth. But let us say if that does not really provoke you into brushing properly, what the app does is it gives you the second screen. Now, what does the second screen do? It scores each of your family members and publishes across the family your scores. So your kid could come up and tell you, challenge you saying, oh, your score of brushing is half of mine. So you could be intimidated, so therefore be careful. So therefore you kind of wakes you up to say, okay, look back at your dental hygiene. Also on the right hand side, if you see, it also tells you over time, how have you been improving or going back on your dental hygiene and your practices. So this is just one of those technologies. You could find humongous amount of them. You got IoT fridges, you got IoT televisions at every home now. There are a whole lot of stuff that's already kind of coming. In fact, if you look at the same use case, the interesting thing was they found that all this works with grown-ups, but then kids don't get really enamored by it. And those are the ones which really eat a lot of chocolates and they spoil their dental hygiene. So what do you do with them? Then they came out with an innovation. They said, okay, there's a game and the kid places the mobile before them when they're brushing. And then you got to make sure you get those points. You got to make sure you pop off those particular demons. And that is triggered completely by how your bristles move right across your mouth. So that is a fantastic innovation which kind of helps kids with a very kind of entertaining pattern to really see how they improve their hygiene habits. This, I would think, is what every engineer has to focus on to say, how am I making a difference with whatever I am doing with regard to the technologies that is ultimately going to be used by somebody. Now, look back, and this is the former chair of the World Economic Forum. Mind you, this is the World Economic Forum, which talks about economics. But then, World Economic Forum of late has been extremely interested more on the technology front. And this was in about 3 years back when Klaus Schwab, the former chair, he said, it's a very profound statement, and each of us need to understand this. He said, we stand on the brink of a technological revolution that will fundamentally alter the way we live, work, and relate to one another. In its scale and scope and complexity, the transformation will be unlike anything humankind has experienced before. And I think already we are seeing much around our lives happening with technology that's kind of changing the way we live, work, and relate to one another. In fact, what we would be scratching during this session, we already started looking at things, and our trust in things is something we have to really look at. Imagine an autonomous car goes berserk and they say, okay, that's a code error 404 or whatever you want to call it. And then you are kind of completely out of control. What do you do? If you can say, oh, that was just a bug in a software, here, that bug in a software could cost lives. So that's where we are coming to a whole lot of what is called as responsible technology engineering, which needs to build what is called as digital trust. And that's where we are going to look at some of these perspectives as we go by. We'll look at some of those risks to the business from the IoT and the cloud. We may think it's good technology, but the business doesn't think so truly. Then how do you go about the approach of assessing and managing all this and building it into your thinking? Well, there are things and more things. If you look at the kind of forecasts, they are mind-boggling. Well, any number of forecasts you could see on the internet. IoT devices, they are going to be 27 billion of them connected to the internet by 2025. You're looking at IoT data already of about 2.5 quintillion per day, which is getting aggregated. They have USD, look at the market, it's about a USD 1.7 trillion with a 20% CAGR, and that's where it is moving to. There are likely to be 470 million connected cars by 2025. But then the question is, How are these going to make a difference to the customer in terms of customer experience, in terms of contributing to internal efficiencies, accelerated revenue and cost savings? So when you are an engineer and if you are not focused upon, okay, which box am I contributing, then I think you are somewhere losing out to someone else in the race who is going to take over from you. And if you look at the applications which are already there, you have industrial IoT in the manufacturing space, in the financial sector space, the healthcare space, mobility, telecom, insurance. Some of them are fascinating IoT applications which are already delivering unimaginable benefits to the customers. And of course, the end consumers, you have food, wearables, health and lifestyle, homes and cars. So there is sensor and of course, every element of our life today. A camera that is looking at you in a CCTV, it could have artificial intelligence, looking at face recognition and trying to tell somebody, well, this guy has been there in this place on so and so and so and so time, so and so places. And tomorrow, as you would know that China already has the entire mapping of all the faces across their population. How much of it is true, we don't know, but then that's practically kind of possible. Well, Singapore already does it because they have the Smart Nation 4.0 program. So there is humongous amount of these technologies which are constantly prying on each of us, each of our senses that we have. If you look at the payment space, which is the most sensitive in terms of the banking finance, you're looking at newer experiences in terms of contextual banking, IoT banking, or what is called as life enabler banking, emerging branch distribution models, mobile banking, social media banking, video banking, smart TV banking, a whole lot of things that are going there. And then of course you have metaverse banking, which is already there. But if you really look at how AI applications are making a difference, I'm sure we can see around us how the Siri, the Cortana, the Google Now, the Alexas, the Google Dots. I'm sure we have many of these which are either at our homes or somewhere we have seen them. And what an IBM Watson is really up to today, the Google DeepMinds, the kind of changes that are brought in terms of efficiencies on energy management, and the Tesla and the kind of technologies that they use across in every aspect of their cars and the gadgets that they manufacture. And of course, we have the Sophia and the robots, which are obviously built on the foundations of AI framework. I'm sure you can recount, this happened a couple of years back, wherein Sundar Pichai, he launched this stunning demo of an assistant automatically fixing a barber appointment for you. So that can give you a sense of where interactive applications are really going. But let's get back to a little bit of engineering and look at what is this architecture that runs an IoT framework. Well, primarily we have to understand there is one very important element which differentiates from all other technologies in an IoT is the sensors and the actuators, which could be either wired or wireless. And mind you, this is going to be a humongous industry in the coming days. Because if you really look at the kind of sensors, they could be simply labels which are simply pasted onto chairs, which can tell you where the chair is moving, what is the state of the chair. You can track a chair, you can do a whole lot of things. So you can build in a lot of intelligence into the sensor. It can even also have a memory, which it can make sure that it is constantly tracking and giving you that information. You already have the EMV chip on your cards, which is already doing a lot of work for you as a sensor. Now, if you really look at that part of it, obviously needs to get to the core. So whatever information that is picked up by these sensors has to go into your data acquisition gateways. And generally that's all running on the internet, wherein the data aggregation happens at this place. And mind you, this is where you are looking at some element of access security, you're looking at measurement, you're looking at control, all that happening at this place. So that's the stage 2 of that. But then stage 3 is where we are looking at tremendous amount of edge technologies, which are looking at a near the user kind of computing, which looks at analytics, pre-processing of your data, etc. All that happens there today. If you look at your mobile banking devices, they kind of implement that already. And then the core of all this data goes into the data center or the cloud, wherein you could have, you could have farms and farms of data servers which are hosting a whole lot of data, and which are, you imagine the number of dimensions of data that you're looking at. If you're looking at your mobile and the kind of data that will send back to your various service providers, it is humongous. It is humongous. That's where if you find the data usage, if you start observing your patterns, unless and until you are careful with your settings, you could be paying a huge data bill. But all this, if you really look at the data flow stacks and the control flow stacks, that is important to understand what kind of technologies go into managing your sensors, managing your aggregations, data aggregation systems, managing your edge technologies, and ultimately managing your cloud. But at the same time, all this has to work as an orchestra. And this is where the challenge for an engineer comes in. You can create a beautiful app or you can create a beautiful appliance, but mind you, if it does not talk to all other appliances seamlessly and at the speed and with the kind of capabilities which are required for that, well, you are not really made a huge difference. So today, everything is about integration. Now, the good question that we have to really ask is, when you are designing something, when you are building something as a technology expert, are you looking at the cyber physical connect risk dimension? And when I say this, what can go wrong with your technology? How many of us will truly think in a structured manner before we really start even working on the design of those technologies? And if you're not going to do that, you could land up with a fantastic, functionally wonderful app or application, any kind of capability that you come up. But if it does not manage those risks, if it rather creates certain risks, you are going to throw it off the very next day. Imagine an ATM wherein 3 out of 10 times your cash gets stolen. Would you be working with such an ATM with your money? You obviously will not. So it's very important that we look, as engineers, look at security by design. And that's very fundamental to today, especially the IoT apps. Because IoT apps, as I said, are the first time the digital talking to the physical and controlling those actions. So imagine a drone which you are on. Let's say you take a drone taxi, and after you are airborne and you're enjoying the beautiful view of your city, there is a voice which tells you that you are being hijacked. Either you pay up through using your wallet 20,000 rupees, or it is not going to get you down. It will wait till the battery lasts and throw you somewhere. You can imagine the kind of risk that it goes through. All because the security gates within the architecture of the application were not taken care of by design. And that can lead to a humongous kind of problem. So please understand that this can cause a huge amount of disruption to human lives in many ways. Recently, you saw the precision attack on one of the top terrorists and how a drone attack was used remotely to precisely locate somebody who was otherwise very difficult to locate and hit that person right on target. Drone technologies are very widely used in warfare today. There is tremendous amount of spying using drones. So if you're really looking at it, there is a whole lot of user level risks which also need to be looked at when you're looking at applications that you're creating intended to benefit people. But mind you, if an autonomous car goes berserk and it doesn't stop and goes and crashes somewhere and you have no control over it, you are looking at taking lives, and you could be charged with murder because you did not consider the risk as part of your technology design. We are in for significant change in the laws, wherein most of the laws are certainly going to become technology centric. There is no two doubts about that. So it is from moving cash to causing harm to people is where you have to look at the embedded risk dimensions. When software can command and control things, but we know that bad guys are there, there was a hack in between wherein I can tell a drone that this is not your GPS coordinate. I can map it to a proxy coordinate and say, now you come to my home, and that's where your destination is. So there are a whole lot of things which can go wrong if you do not manage the security side well. The IoT customer experience data decides for you today. Look at the Zomato ad. It says, we will tell you what you will eat by 2023. And that's scary in a way because you are dictating my food habits. You are dictating, it is a kind of a national security issue if you are going to change the culture and make people believe strongly that this is what I must have and not something which I have been used to having for so many generations. So these are very, very sensitive issues. And your terms and conditions, we never look at those terms and conditions. If you look at the WhatsApp terms and conditions, you have very less control over your data. Let's be clear. It talks about end-to-end encryption. If you really looked at very closely at the model, it has a lot of pores in that model. And if you look at the supply chain maze, when you are doing an online banking transaction using your mobile, let's say you are buying a mobile using your mobile app, imagine how many vendors does this transaction traverse through? And it just takes split seconds to really make those decisions. The big question is, are risks managed in every architecture right across this path? We only are focused upon, oh, my organization, my risks, we are doing good technology that we use. But if, let us say, an integrated technology can bring in risks through your back door, then we are really not really looking at anything seriously. Who's peering on your data? That's a big, big challenge today. I mean, we keep on giving access to so many of these apps to say, okay, accept these cookies, accept this, accept that. But are we really looking at the risk of connected supply chain? And mind you, we are not very far away from a cyber warfare. It could have happened recently when one of our enemy countries could have launched a very widespread attack. We already are seeing that in Taiwan. I'm sure you read about a story of a small country called Estonia and how the entire country was brought to its knees by a cyber attack. So if you're going to ignore that, we are going to throw the baby along with the bathwater. And that's where it is important to understand that our lives, the psyche is not just only looking at the positive side, but also subconsciously managing the risks. When you're crossing your road, imagine the amount of programming that goes through your brain. And especially when you're simply darting across by talking on your phone across a very busy highway, you can imagine the amount of complex programming that goes through in your mind. But mind you, when you're trained to do that, you do it very well. Are our technologies now capable of learning that much is a big question mark, whether we'll be able to do that in the near future. So vulnerabilities of the IoT kind, the big problem that's going to happen is the hardware is getting cheaper by the day. The sensors are going to be throwaway sensors. That's what is going to happen. You're going to find enormous IoT idle capacity. You'd be fixing sensors everywhere. And after some time, you decide, no, I'm not going to use them. Are you going to pull out all those sensors is the big question. You're not going to do that. So which means many of these sensors either say active or more dangerously, they are a dormant risk. So is there a way that you could make these disposable sensors die after their use is done? Very difficult to do that. And we are moving into intrusive attacks because, as I said, you could detect a particular person and you may want to either shoot a movie upon them, or you can simply kill them, or you can steal something. Drone thefts are already happening. So these are going to be very, very kind of difficult dilemmas that we are going to look at. How do you go about patching IoT devices which are all over? How do you make sure that the sensors, if you have to run a patch on them, how do you make sure that these programmable sensors would be patched? This is going to be a humongous task because as you start discovering those, the bugs in the code, or you could even be a bad design, how do you go about, plugging all that before it causes harm or a bad guy takes over? So unfortunately, there are a lot of IoT standards, but they are not keeping pace with the kind of emerging models and innovations. So it's going to be a very big challenge, but I would suggest that when you're designing anything, make sure that you have your finger on standards like the NIST, which kind of give tremendous amount of insights into principles of how risk resilient architecture needs to be built. So you got to look at security agnostic device design, which is a big challenge. and unregulated manufacturers. If you really look at the mobile phones and rooted mobiles, wherein humongous amounts of the Chinese manufacturers and all who are kind of dumping bad mobile architecture into the market, which obviously leaks and sometimes can be even dangerous in terms of the quality of technology. And the insiders is always a threat because organizations are wary, especially when you say you can work from anywhere. My biggest challenge is your endpoint when you're working from home. And how do I make sure that I manage that? And the big green problem of e-waste. We are going to look at IoT creating the kind of e-waste which you have never imagined before. The amount of sensors that are going to be, in an autonomous car, if you look at the sensors, there are about 2,500 sensors that can come up and which are working there. But then what is going to happen to those sensors which are going to be embedded right across in every part of our environment is a big question mark. So clearly the current approaches to risk management vis-a-vis your technology, design, development, testing, and deployment are redundant when it comes to IoT. So you need to really look at, making sure that those are plugged in. I mean, let's take this. It's not something, this I'm talking about as old as 2019. This girl, Dorothy, I'm sure some of you have read about it. She has been crazy about mobiles. She cannot live without a mobile. Now, what this girl does when her mom kind of takes away her mobile forcibly, she is trying to tweet through the fridge. This is crazy, right? So this could be an example of backdoors which can be utilized. And please remember that we had the Mirai botnet attack, wherein how teens were able to use the various IoT device to completely bring down a part of the internet. This is scary, but then this is real. And if you really look at this, I'm sure you recognize what this is. Pokemon Go, the game which caused a stampede in Thailand. So these are kind of things. The PUBG kind of craze is clearly crazy, which means that as a hacker, if I look at your vulnerability, I can hook onto you and make you do anything once I bring your psyche into my circle of trust, which is dangerous because your gadget does not protect you against those things if your mind goes berserk. There are a lot of threats. I'm not going to go into each of them. There is actual mass real world use of breach credentials in the dark web. Most of our credit card numbers and details are already available. It's a question of when are we going to get hacked. The home networks in the work from home scenarios already expose enterprises to BYOD like connected risks. Innocent victims get caught in crossfire between countries when attacks go. If you remember the Kudamkulam plant, one of the part of the servers were completely taken over by a group of hackers called the Lazarus group. The City Union Bank and the Cosmos Bank got attacked by a wonderful, completely architected attack, which took over their entire ATM switches. And the hackers were able to withdraw 74 crores of rupees right across 28 countries with more than 15,000 transactions right across, just in a matter of hours. All this made possible by loopholes that we as developers leave in technologies and integrations especially. So 99% of the exploit which are based on attacks of zero-day vulnerabilities, you are looking at worm wars which are now already targeted on CCTVs. I'm sure you have looked at many of these search engines which help you to trace IoT devices and your SSIDs which you use at home. It's very easy to do that and enter into them. So more nations are already developing very offensive capabilities when it comes to IoT technologies, breaches, supply chain attacks, a whole lot of social engineering attacks, cyber espionage, cyber crime, whole lot of things which are really going on. And this was way back in 2001, mind you. So you have IoT attacks are not new. When a hacker who are jailed actually for revenge, because what he did was he did not get his appointment in the organization of his choice, which was a corporation or a county in Queensland, somewhere in Australia. And what he did was remotely open the shutter gates of the sewer pipes, which actually dumped all the sewer onto the lawns of a five-star hotel. And you can imagine what it would look like. So very important, you look at the big picture. One, who is going to be benefited, who is going to use whatever technologies that you're building. Popular endpoint devices across shareholder sets today are very powerful. So you need to understand, how do I containerize this environment? Nature of impact could be in terms of business, benefits, laws, services. Also, you have to align with the enterprise goals. Your entire IoT architecture need to be aligned with what is going to be or should be customizable to the type of business. You cannot have the same level of architecture for a banking application as compared to a autonomous car application. They are completely two different things with different levels of risk. So you got to look at those foundational principles of security architecture and build it as part of your design. And integration architecture is always a sore point, because you could have your a technology piece with a very secure architecture, but if you're connecting or trusting any device or any app, and if that's not equally secure, you are entering into a very, very sensitive state. So you're looking at a backdoor which can completely take over your architecture by bad guys. And if you really look at what's happening, this is actually slightly old news, but mind you, we are looking at all this already happening. The Singapore has already tested out a volocopter, which is a kind of a prototype, flying taxi station. You're looking at Uber, which is already looking at investing huge money in self-driving cars. Google has already launched it across its campus. Singapore is testing full-sized Volvo bus, driverless buses. We are already trying that somewhere in Telangana. I'm not sure how serious it is going to be. You're looking at M2M payments, wherein your entire, utilities like your power service would be automatically, tapped. They know how much you are using. It could automatically generate the bill and send it to your mobile. And if you authorize, it will automatically debit it to your banking account. But look at the risks of this integration, which is going to take place across different organizations, publicly open devices and systems. And unless and until the devices, the network and sensors are by design secure, we are not really talking any terms of doing good to the mankind. Excuse me. So I'm just going to skip this because this is slightly on the GRC side, but these are important and we don't have the time to discuss all this. But mind you, you cannot take lightly the regulation today, especially because it is a regulation of data, what systems can do. The Information Technology Act 2000 is a very powerful piece of regulation in our country. And mind you, it can throw any person. Earlier it was the technology guys were always, quarantined from such impact, but no more. You are not insulated anymore. Every person who is responsible for at that point of time can be jailed. So you have to look at lot of responsibility and accountability when it comes to portability, interoperability, lifecycle management of data, and compliance, taxation, audit, whole lot. So of course, the connected risk I have already talked about. And if you really look at the banking of the future obviously, as even the largest bank in the country says, the bank is in your pocket. So you're looking at the future of banking, which is going to be completely device driven. If you are going in your connected car, you have no driving to do, and obviously you will be sitting and shopping, and you'll have a payment gateway which is right stationed within your car, and you could be driving a lot of merchant transactions through that. So you're looking at a lot of integration with sensitive systems, which can create a complete new set of risks. And MasterCard and whole lot, they're already testing out different devices. I'm sure you have seen these devices. There are this magic ring, which you can use it for making payments. You've got the magic watches, which also are NFC enabled, and you can simply touch and make those payments. And India has already tried this out. How to reach cash to the remotest places in our country. There are projects which have already taken off, wherein you deliver cash to people. But imagine if you are a pirate and you can shoot down this drone or program it to come to your home. So thank you so much for the cash. Singapore is already testing out its ATMs, which are autonomous, which detect problems, automatically correct it. So that's already a kind of technology which is on. And if you look at the implementation challenges, there are lots of them. How do you inventorize how many of these devices have been put in by an organization? Which technology is working down? Which protocols work on this? Are they secure or not? Are the certificates which are working in terms of the encryption on these, whether it is the channel encryption or in terms of encryption of the database, are they really working or not? These are humongous questions which still don't have answers. So you got to look at assessing risks right at the design stage of human lifestyle risk, sentiment risk, connectedness risk, authentication risk, beside all other technical risks that you have been looking at, because these are something which are getting more human now. So your manual risk registers and whatever that you were driving earlier, none of this is going to work. The traditional management techniques are of no more use. You need to look at real-time IoT threat intelligence so that you can quickly get to the problem as soon as it is. And you already, I'm sure, seen ads from BBC wherein you have one of the aspirants, embedding a mobile into their hand, and you use it as a mobile. That microchip is used as a mobile. You can receive calls, you can make payments, you can do a whole lot of things. But then the big question is, you would tattoo your, possibly your body somewhere, but then would you be okay with a microchip implant? Well, we already have very autonomous advanced pacemakers which are doing wonders for saving human lives. So from an engineering guide to IoT, this also applies to the cloud. First of all, you got to be clear about the purpose of whatever you are doing. And when I say that, who is going to use it? How is it going to impact those who are in the society? Ultimately, how long do you across the life cycle of this device or this technology really look at that happening? Are you clear about the path that the data takes and what kind of data is used? One is, it could be a simple banking data, but imagine, as I said, your sentiment data. You know what happened in terms of the US elections, where the entire psychometric analysis was used right across Facebook to judge what people are thinking and make them think differently. So you are looking at tremendous amount of problems and all that, wherein you are pushing risks and threats into the network. So inherent vulnerabilities, instructions and actions to command centers, to devices, and how do you really look at managing all that using your architecture? The partner connects, and what kind of connect could happen in the future, we don't know, because we are looking at smart cities. How do you manage compliance on the fly? Whole lot of things. So when you are looking at, I would call it mundane things as an engineer, as sensors, devices, edge, cloud, application hosting, blah, 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 you got to now put a human angle. You got to put now an economic angle. You got to now put a very clearly an ecosystem angle to that right at the time of design. Otherwise, we could be putting the entire humanity at risk. So that's why you have a lot of IoT risk assessment methodologies, which I would urge you should look at, and you can pick them up from the standards which are already available on the internet. You could look at NIST standards, you could look at ISACA standards for those, which are pretty useful, I would think. Now, coming quickly to the cloud, I would touch upon certain aspects of the cloud in the interest of time. I would rather like to have a little more time for question and answers. But why would somebody go to the cloud? Obviously, one of the first reasons is its savings as of now, as it looks like. Oh, it comes at dirt cheap rates. But then it also looks at all the hassles of managing all those technology not being there. And you can scale as you go. It is like you drawing electricity from a grid. Oh, if you want more electricity, you just pay up for that by meter and you're done. So you don't need to really go about completely rewiring your entire hardware and software architecture in your firm. So all that kind of takes off the pain from the business to focus on their own business rather than looking at managing technology. So you also have access to powerful applications today, the SaaS applications, the business process automation. Then of course, you also take care of green IT, because if you were to manage all this within your organization, you wouldn't be having the wherewithal to make sure that you are complying with the green principles. And data availability and security also generally is believed to be taken care of when you go cloud. But then of course, it's always with the riders, and your data is available anytime, anywhere. You don't need to look at locational dependence for whatever. So huge or tremendous advantages of glowing clouds. And if you really look at the surveys that have been done right across, organizations always agree that it looks a fascinating experience in terms of the business benefit to go on cloud. But the problem is to have the right cloud strategy. And that's where the whole problem really thinks. Everybody thinks, okay, if I go to the cloud, all my problems are taken care of by the cloud service provider. I have nothing in terms of responsibility taken care of, which is a very big mistake. And that is where it is very important to understand who is your cloud service provider, what kind of architecture do they use, is it secure by design, is it implemented secure by design, and being a shared model, how would you get an assurance around that it is fine when you enter the cloud service provider and will stay fine right throughout as technology advances. So these are very, very sensitive questions. And if you really look at, there were a lot of problems with the cloud. Everybody thinks, oh, if you put onto the cloud, there is no need for backup. Cloud takes care of it. No. Cloud being not properly understood has killed organizations. And we would see that some of them, which are pretty scary in terms of if you really look at what has happened with the problems on the cloud. And if you really look at the ransomware attacks on cloud have taken down even the Microsoft 365 servers for a while. That has happened. And if you are looking at, the attacks, obviously, this is like a chest wherein you have everybody's cash in. So hackers love that, because if I break through those defenses and I simply focus on, this particular, the top 3 or 4 cloud providers across the world. And if I simply focus on them through multiple of the back doors and the front doors, I could get across to valuable chests of information, which can be used in so many different places by them. So we have to understand that when it comes to cloud, what is a cloud technology architecture look like? I'm sure you heard about the different implementation styles. You could have public clouds like the Amazons, the Microsoft Azures and all over. Or you could have a private cloud, which within a group of companies, you could set up a shared service architecture, and that could become a kind of private cloud. You could have hybrid cloud, wherein you use the private cloud as well as the public cloud, depending upon the sensitivity of the data. For example, if you look at the payment data that you use with regard to your card data or your UPI data, all that is highly sensitive and regulated to be not sent onto the cloud, which is outside the country. So these are mandated by the Reserve Bank of India. So you got to make sure that all payment data has to be lying within your own controlled cloud centers or within the geographies. You cannot put such data outside the country. But you could certainly put certain other data like a marketing data, possibly those servers or whatever on to public clouds. And you can have more than one cloud. There is obviously no dearth. I'm sure all of us, when we use a Gmail or Hotmail, whatever today, we are all on cloud and we use tremendous amount of G Suites, the Office 365s and whatever. All that is cloud if you really look at, and these are all what we call as the SaaS applications, the software as a service applications. And you don't care, you simply subscribe to the service, and well, if you are going to pay by meter, as they say, you just pay an annual fee or according to use as AWS does, and you pay by the meter and you are done. So your computing is on tap. So if you really look at this, the compute, the storage and the network, those are the 3 critical parts, and all that gets managed as part of the platform. And further down, you could have the infrastructure as a service. So it depends upon what kind of service you really want to get. Those kind of stacks are already available right across. If you look at a reference architecture, this is from IBM, and to understand it closely on how the cloud technology works, you have to understand that the cloud technology is a shared model. So which means that multiple organizations, each of them who consider their data to be sensitive and not shared with anybody else, especially their competitor, are trusting the cloud to say that you shall keep this confidential and secure. And that requires a tremendous amount of Chinese walling within your architecture, logical and physical controls right across the compute, the storage, and the network aspects of your architecture to make sure that this is achieved. Easily said than done. So if you really look at the different cloud services, as we see in the centerpiece, you have the business process as a service, software as a service, platform as a service. infrastructure as a service, the control completely varies. On an infrastructure as a service, I would rather simply go down for a hardware and a basic capability of infrastructure, and I could host my own platform, I could host my own applications, my data, everything under my control except you providing me the platform. That's it. Whereas if you look at a platform as a service, you are going in for, okay, I'm going for a Wintel server which is provided on the cloud, and I could say, okay, I could now then host my own applications on top of that and my data all within my control. But when you look at a SaaS service, you are looking at an application along with the database capabilities and the entire architecture and the infrastructure coming to my service. And I don't care. I simply use a Gmail or a G Suite or an Office 365 app. But mind you, each of them has to deliver robustly. You can't have downtime. You can't have cyber threats which are looming large. You got to make sure that the service is perfect. It is intuitive. You are offering value. All that needs to be built as part of your design. And then you have an entire business process, an ERP as a service, where an entire organization goes each department by department, function by function, process by process onto the cloud. That can be humongous because you are looking at the entire organization spread across the globe going onto a cloud. So each of them, if you see, the business risk varies, the data risk varies, the technology risk varies. Obviously, your technology design needs to provide for each of these flavors of needs. So that is where, if you really look at, you need to look at building A, security, B, resiliency, and consumability, if you see in the bottom of that. But mind you, when you look at that, a software as a service, let us say a Gmail or a service offered, may be using certain other open source components from other vendors. Google often takes over several of these smaller firms, or they use their services. I'm sure you see that. They buy these technologies, they partner with them, they use that as part of their architecture. And you will see that many of those extensions in Google browsers and the kind of apps that are available to you, which you can integrate with your Android platform or whatever, all these are external integrations, and they are developed, owned, run by different entities. So the big question is, can you hold Google responsible for the performance of those applications and components as well? Obviously, the answer would be a big yes. If your bank is using partners and if your cash is lost online, would you hold your bank, or you simply go to say partner and start conversation with them? So these again go back to your integration architecture of the entire technology. The APIs are a big boon, but a big curse as well, because the APIs can do tremendous damage to an organization if they are not properly secure. And today, unfortunately, many organizations don't even look at API security properly. And that's where the whole problem is. If you really look at the security aspects, which includes, among others, identity access management, who can do what on your platform, on your cloud platform, is a big question mark. How do I, as a consumer of your service, have the guarantee that one of your employees is not prying on my data or selling it outside, or could be even your partner? How do I make sure that the employees who are terminated are removed from my system? How do I make sure that systems which are having trust relationship one another, when they are shifted out, the loop is not open? So these are sensitive questions, some of them. And then, of course, you have questions with regard to how do you help discover and excuse me, and categorize and protect the various aspects with regard to the information systems, your systems development protocols. How do you make sure security is driven as part of your development architecture, your build architecture? Is it something that you do a secure coding by design, and all that ties down right across the stack? And then you also have a problem management and risk management capability, which also is reasonably autonomous, because in a cloud, you're looking at continuous service. You can't bring down the service for running a patch, let's be clear. So you got to look at resilience architectures, cloud governance models, which kind of look at supporting this whole thing without compromising on the consumability, which is ease of doing business, various aspects like readability, user experience, etc., etc. As you and me as Gmail users, we don't even know when a patch is run. We don't even know when the antivirus is working or scanning something. All that is happening somewhere in the background. But then it is so complex in terms of the architecture when you're looking at across the stack components all working as an orchestra is pretty serious affair and a very big challenge to really make happen. So there is need for integrated approach to security and transparency. Chinese wall strategies got to be implemented to protect customers from prying on each other's data. Several others, I'm not going to the details of that, incident response, application security, encryption is foundational to the entire security architecture. So you got to look at identity management, encryption across. When you say, today we are talking about homomorphic encryption. When you are processing private data in the memory, in the CPU, it could be protected across the channels, but a hacker could do a memory attack or a buffer overflow attack and leak out this data. How do you make sure that still you would be able to comply with the regulations of privacy and not compromise your architecture? And that's where the techniques like homomorphic encryption can be of tremendous use. You also have electrical cryptography, you have quantum cryptography, which are all kids on the block, which are going to be the future. No doubt about that. Tokenization is already in, which is a fantastic way of protecting your data. You have anonymization techniques, which are used widely. So all of us as engineers, you've got to be clear about how these technologies work. Well, here's a lighter one for that if you're finding it too difficult. Well, not sure if it still works. So you have to have your eye very keenly on the service and technology architecture that you're building out. Not simply just focus on to say, oh, I am building these small components, I don't care about the rest. No, you can't be like that. You've got to look at scalability when it is a cloud architecture, shared infrastructure and the security issues, robust components, mirrored data farms. These are something which are part of any cloud architecture. And the cloud service provider versus the consumer controls and the responsibilities on each side is a very difficult proposition. When you are having your container, can the cloud service provider have access? The answer is no. But then with regard to your cloud container, you should be managing your own security. And that is where the clear breakup of responsibilities need to be agreed upon. If you look at a virtual private cloud that VPC that you could be operating or virtual machines, all that needs a container security, processing security, APIs, integration security, network, mobile security, because you are working on multiple devices which are interconnected. And encryption obviously is one of the foundational technologies that helps there. And also the problems of managing service, change, patch, problem, incident management, resilience architecture to make sure that clouds don't become a single point of failure, robust monitoring, surveillance, continuous vulnerability management given cyber war as a potential risk. And mind you, we have had instances wherein cloud has killed organizations like this one. So what is the answer? Well, you got to learn, and there is tremendous amount of guidance available. The NIST, this is a cybersecurity framework, but you have many standards which are available from NIST, IEEE, TUV, and a whole lot of stuff which are something which can help you in your entire development strategy. So while you have the cloud model, which is a technology stack, you got to integrate the security and the compliance model and interweave them. Otherwise, it's not going to work. You cannot say, okay, I will look at GDPR compliance after it is implemented. Those days are gone. Your GDPR compliance principle got to be architected into the base of your technology architecture. Otherwise, it's not going to work. Because when you're looking at protecting privacy data on the fly, you're looking at a schema level security, which needs to identify, have a label around saying that, okay, this needs to have a hardware level encryption going through this. So just an example. Tomorrow we are going to get into smart cities, and that's crazy because you look at every organization having an open data architecture, interacting with each other. You get on today, if you look at Singapore as a nation, if you enter Singapore and till the time you leave, the government knows where you were, what you did, how long you were there, what shopping did you do, where from did you pay, what are you doing, everything is there as part of the surveillance. Now, there can be questions around privacy versus surveillance. Well, that's a national security issue. Every country handles it differently. So a lot of GRC risks, which you should be aware of. confidentiality concerns, what goes into the agreement, which is important. And if your architecture does not promise that, you are in for a huge amount of hassle around that. Your security management, ease of managing security, autonomous security, all that got to be again built. As I said, the regulatory considerations are not something that today's engineers can ignore. You got to make sure that's done. And your resilience, as I said, how often can your technology be made to fail, made to deplete, made to have a entropy curve and become, obsolete, but yet not leak data. And obviously all of that has to provide auditability, wherein it is a kind of a security breach in a way, because you're giving access to someone to look through very sensitive data, yet they should be able to do it securely and provide the governance. So why govern clouds? As I said, responsibility versus accountability, question of who's in control of what's yours, business context, risk context, regulatory context is something every engineer cannot miss in the coming days. And mind you, if you look at the security challenges and in the cloud, there are humongous. They are becoming more and more severe as a lot of IoT stacks are getting integrated into cloud stacks, which is a normal kind of thing which is to expect. So you have hits like ransomware attack, which can completely paralyze an entire cloud architecture with the IoT. So a lot of standards, which I think we have to take cognizance of. There are many of them which are, as we speak, we have more standards coming up. So ultimately, if you really look at what World Economic Forum, which, as I said, was a mundane organization looking at, the things of just economics, money, today says your robo personal assistant will know when you are stressed, tired, or hungry. And there is a technology stack which is working and talking to each other behind all this. But mind you, it will also do your banking. It will also take care of all your investments. And it is obviously going to be prying on your lives, because if you want to give access, you know that. And you have already heard about the Alexa spying case, wherein Alexa, which is sitting in your home, is quietly kind of prying on your conversations within home and leaking that out. Your smart TV could be doing that. Your own mobile phone could be doing that. So these are all issues which I think as engineers, we need to take very seriously. I just stop here with my favorite quote from Bhagavan Ramana Maharishi. Your own self-realization is the greatest service you can render to the world. Happy to take any questions. Of course, happy to also connect with any of you on LinkedIn. It'll be happy to connect more and more and interact, discuss more, learn from each other. Thank you so much. Back to the hosts.
Yeah, thanks. That was a great talk. So I don't see any questions from the participants, so I guess we'll proceed to a vote of thanks. Yeah.
I hope it was useful and comprehensible, or possibly.
It was a very insightful talk and perfect training session for the students, especially, sir. And you have touched upon all the issues and also how to be careful on cybersecurity things. And it was very useful for everyone. Thank you so much for your time.
I would be happy to have questions from students, because you must ask questions as students.
Yeah, correct. Any questions from the participants?
Okay, you can always connect with me on LinkedIn.
Yes, sure.
Great to converse on that.
Yes.
Thanks again to IEEE and everyone.
Thank you, sir. Over to Professor Usha.
Yes, madam.
Yeah.
Yeah, I am Dr. Usha Rani, Associate Professor in RV College of Engineering. I take the privilege of thanking Mr. Vittal Raj, who gave a wonderful talk on IoT and cybersecurity, and he's put insight on the IoT sensors and the e-waste generated on the IoT sensors, and also the security issues in the banking services and etc. So it was a wonderful talk, sir. Thank you very much. And I also request the students and student branch counselors to contact Mr. Vittal for any help regarding this issue. And also, if they want to have some activity with respect to this IoT and security, they can contact Vittal, and also they can claim for the AICTE activity points in association with their student branch counselors. Thank you very much, sir. Thank you for a wonderful talk. On behalf of IEEE site and IISc student branch. Thank you, sir. Thank you very
Thank you, Dr. Usha. Thank you so much. And let me just end with this to say that cybersecurity professionals are in great demand. And you have to understand that as we go more and more of digital world, digital India, you got to have engineers who understand business, who understand regulation, who understand risk, and who understand security, and make sure that you are protecting organizations right from design to the entire life cycle of security management. There is a whole lot of demand for professionals. We don't have cybersecurity professionals today. I would urge those of you who are interested in this line to take up this as a career. There is humongous opportunities. Let me tell you that much. So that's just with the parting thought. Thank you so much.
Thank you, sir. Thank you for a nice advice. And we request all the students to write us back, and we will be sending his contact details to the mail and for the registered.
I'm just giving my contact in the chat box also.
Okay, that's
any
it.
of them who wants to reach out to me, they are most welcome to do that.
Yes. Okay.
Thanks to IEEE, thanks to everyone, Madam Anandi and Dr. Sangeeta, Supriya, Kunal, Dr. Usha. Thank you so much.
Thank you, sir. Thanks again.
Thank you, sir.
Thank you, sir.
Yeah, thanks.